Welcome back, everybody, to another deep dive with us. Today, we're going to be talking about something pretty cool, multimodal retrieval. Have you ever, wished you could search using both text and images? If you're trying to find that perfect vintage lamp online, but instead of just typing in vintage lamp, you could also show the AI a picture of the style you have in mind.
Yeah, that's exactly what multimodal retrieval is all about. It's like the superpower for finding information.
Oh, I love that. Search with power. But,
Yeah.
just like any superpower, it needs some serious fuel, right? And these AI models that make it all happen, they need tons and tons of data to learn. But getting that data can be a huge challenge. And that's where things get really interesting. There's this new method called MegaPairs, and it's kind of changing the game.
And what's really fascinating about MegaPairs is that it actually needs a lot less data than traditional approaches to actually outperform them. I mean, we're talking like up to 70 times less data for even better performance.
Wait, 70 times less? Okay, I'm all ears. Before we get into the solution, though, let's talk about the problem that MegaPairs is actually tackling. So traditional vision language models, or VLMs, they're really good at basic image-text matching, but they struggle with these more complex tasks that combine images and text. It's like they can ace a vocab quiz, but they can't write a poem.
Yeah, that's a great analogy. One specific area where these models need some help is something called composed image retrieval, or CIR. It's kind of like saying to the AI, find me a picture similar to this one, but with these specific changes, which actually requires like a much deeper level of understanding.
Okay, so how does MegaPairs come to the rescue then? What's the secret sauce?
Well, instead of using these carefully curated and labeled data sets, MegaPairs actually focuses on something called open domain images, which are those images that are, readily available online. So just think about the sheer volume of images out there on the internet. This makes MegaPairs super scalable.
So they're basically using the entire internet as their training ground. It's pretty revolutionary.
It is, but it gets even more innovative. MegaPairs uses this concept called heterogeneous KNN triplet. Essentially, it analyzes relationships between images using three different similarity models.
Three different similarity models. Okay, I am all for teamwork, but break down for me what each of those models is looking for.
Sure, so the first model is looking for visual semantic correlation. So it's not just about finding images that look similar. It's about finding images that share a similar meaning. So, for example, pictures of different breeds of dogs. Even though they may look different, they all share that underlying concept of dog.
Gotcha. So it's like understanding the essence of the image, not just the superficial appearance.
Exactly. Then we have the second model, which looks for visual pattern correlation. So similarities in, background styles or composition, like pictures that are all taken at the beach or pictures with like a vintage filter. Even if the subjects are different, the overall vibe is similar.
Okay, so that's capturing the artistic style or the context of the image. What about the third model then?
All right, so that one focuses on caption correlation. It analyzes how similar the descriptions of two images are, even if the images themselves look totally different.
Wow. So by combining these three different perspectives, MegaPairs is giving the AI this much richer understanding of how images and text relate to each other. It's like having a panel of experts, each with their own expertise, weigh in on a single image.
Precisely. This multifaceted approach is actually key to MegaPairs' success.
Okay, so we've got all these diverse relationships between these images, but how do we turn that into data that an AI can actually learn from?
That's where VLMs and LLMs come into play. So VLMs are vision language models, like one called InternVL 226B. They analyze all those image relationships we were just talking about.
Okay, so the VLMs are doing the initial heavy lifting, understanding the images.
Yeah.
Then
Then we have the LLMs, which are the large language models. LLMs are kind of like the wordsmiths of the AI world. Specifically, an LLM called Llama 38B is used in MegaPairs. And they actually do two really crucial things. First, they take that visual analysis from the VLMs, and they translate it into human-readable descriptions of the relationship between those two images. They bridge that gap between what the AI sees and what we can understand.
So it's not just like a bunch of code and numbers. We're actually getting an explanation in plain English. I like that. You said the LLMs do two things. What's the second thing?
The second thing is really clever. The LLMs actually use those descriptions to create search instructions. So they're basically teaching the AI how to search for similar images based on both the text and the visual cues.
Wait, so they're not just explaining the relationship, they're also writing the instruction manual for how to find more images like it.
Exactly. And what's even more exciting is that all these models used in MegaPairs are open source, meaning they're freely available for anyone to use and build upon.
Open source? I love open source. Okay, I'm officially impressed. But let's talk numbers. How massive is this MegaPairs data set?
Well, so far they've created over 26 million data instances, and they're using a subset of this data set called data comp, which itself contains 20 million captioned images.
26 million instances. That is huge. And remember that stat we talked about earlier where MegaPairs needs way less data to outperform other methods. How much less are we talking?
Well, that's where that 70 times less comes in. A model trained on just 500,000 megapair samples, which is a tiny fraction of that full data set. It actually outperforms a model trained on 36.7 million samples from a previous method.
Hold on, let me get this straight. 500,000 is beating out 36.7 million. That's incredible.
It is. And to really put megapairs to the test, they've created a bunch of what they call multimodal retrieval models, or MMRET models, trained using this data. So you've got MMRET base and MMRET large, which are built on a model called CLI. And then there's MMRET MLLM, which is based on LIV 1.6, which is a very powerful multimodal language model.
So they've got their champion models ready to rumble. I'm on the edge of my seat here. We're going to find out how these models perform when put through their paces in real-world tests. Sounds like we're in for some seriously impressive results. Okay, so we've got these MMRET models all trained up on this MegaPairs data, ready to show off their skills. How do they do? What kind of tests they have to go through?
Well, they went through a battery of what are called benchmark tests, which are essentially standardized exams for AI. One that was particularly challenging is called Circo. It has a huge data set of over 123,000 images, and it's specifically designed to test composed image retrieval. That really tricky task we talked about earlier, where the AI has to find images similar to a given image, but with those specific changes.
Circo, huh? Sounds pretty intense. So how did our MegaPairs trained champions fare against this formidable opponent?
Well, they aced it. MMRET MLLM, the one built on that powerful LVA 1.6, achieves state-of-the-art zero-shot performance.
Zero-shot performance. Remind me what that means again.
All right, so zero-shot means that the model was able to perform really well on Circo without any specific training on Circo's data beforehand. It's like, taking a test in a subject you've never studied and getting a top score.
Wow, that is seriously impressive. But Circo wasn't the only benchmark, right? What about those other tests like SCIR, Fashion IQ, and Genesis?
Yeah, so the MMRET models consistently excelled across all of those benchmarks too. On C and Genesis, MMRET, MLLM, again, achieves state-of-the-art zero-shot performance. And it actually outperformed models trained on other data sets, even some that were trained on much larger data sets.
So it's not just a one-trick pony. It's really proving that this MegaPairs data leads to more efficient and accurate AI models. What about the smaller MMRET models? MMRET base and MMRET large. How did they do?
Even those smaller models performed really well. They actually surpassed the performance of some larger models that were trained on different data sets, which really speaks volumes about the quality of that MegaPairs data itself.
It's like having a world-class coach. Even if you're not the most naturally gifted athlete, you're going to see incredible improvement. Okay, so we've seen MegaPairs just shine in these image retrieval tasks, but can it handle other types of challenges? Is it like a specialist or is it a multi-talented AI?
That's a great question. And to answer that, they put MMRET through a different kind of test called MME, which stands for Massive Multimodal Embedding Benchmark. MME is like the decathlon of multimodal AI. It tests a wide range of skills like classifying images, answering questions about images, even understanding spatial relationships within an image.
MEB, the ultimate test of AI versatility. So how did our star athlete perform in this multimodal decathlon?
Well, once again, MMRET MMLM demonstrated its incredible capabilities. It achieved state-of-the-art zero-shot performance across all of MMAB's tasks, which means that this MegaPairs approach isn't just limited to image retrieval. It has the potential to revolutionize a whole bunch of multimodal applications.
Okay, color me impressed. MegaPairs is officially a rock star. But I'm always curious about the why behind the what, What is it about MegaPairs that makes it so successful?
Yeah, so the researchers dug deeper into that very question. And one key finding was that MMRET's performance consistently gets better as you feed it more MegaPairs data, which means it's a highly scalable approach. The more data you give it, the better it gets.
So it's a model with a growth mindset. I like that. What other insights did they uncover?
Well, they also found that incorporating these challenging examples, sometimes called hard negatives, during training, it actually makes the model more robust and accurate, kind of like training for a marathon by running uphill. It pushes that model harder, leading to greater gains.
Makes sense. You don't get stronger by taking the easy route. And what about those 3 different data pair search strategies? Visual semantic, visual pattern, and caption correlation. Did they experiment with using those individually or in different combinations?
Yeah, they did. What they found was that using all 3 of those similarity models together, that heterogeneous KNN triplet concept we talked about, consistently produce the most robust results across all those benchmarks. It's like having a team of experts with different perspectives. They kind of complement each other and achieve better outcomes together.
It's the power of teamwork. But in AI form, MegaPairs is like this well-rounded team, using a variety of strategies to achieve success. So far, we've talked a lot about the impressive technical achievements of MegaPairs. But what does this all actually mean for the listener, you know? How could this impact their lives?
Yeah, that's a great point, and that's actually what we're going to dive into in the next part. The really exciting potential of MegaPairs to change the way we search and interact with information in the real world.
All right, so let's talk about the grand finale here. We've seen how MegaPairs is, revolutionizing multimodal retrieval, but I want to know, what does this actually mean for me? For like the average person? How will this change how we search and, interact with information?
Yeah, that's the exciting part. MegaPairs is really paving the way for these much more powerful and intuitive search experiences. And this is across all sorts of areas, from shopping to research to just finding what you need online.
Okay, I'm intrigued. Give me some real-world examples. Let's start with shopping. How could MegaPairs change e-commerce?
Okay, so imagine you're trying to find like the perfect pair of shoes online.
Mm,
And you have this specific style in mind, but you're having trouble finding exactly what you want using just text descriptions,
yeah.
you know? Well, with MegaPairs powered search, you could actually show the AI a picture of a similar shoe. Maybe it's from a magazine or, even just a sketch that you drew. And then the AI could find shoes that match both your visual input and your text description. Like if you said comfortable or good for walking.
So it's like having a personal AI stylist who understands both your words and your visual preferences. No more endless scrolling through, pages of search results. Okay, that's pretty cool. What about applications beyond shopping, though? You mentioned research. How could MegaPairs be used in like a scientific setting?
Oh, for sure. One area where it could have a huge impact is in medical imaging.
Yeah.
So let's say a doctor is, examining a patient's x-ray
Mm-hmm.
and they want to find similar cases or research articles
Mm.
based on specific features in that image, like a particular type of bone fracture or, a suspicious shadow. Well, with MegaPairs, they could actually use the x-ray itself as part of the search query, which could lead to much more accurate and relevant results, potentially speeding up diagnosis and treatment decisions.
Wow, so it's not just about convenience. It could have like life-saving implications. That's amazing. You also mentioned online search in general. How would MegaPairs change the way we use search engines like Google?
Well, right now, we're pretty much limited to searching with text, right? But with MegaPairs, we can move towards this more visually driven way of searching. So for example, let's say you're planning a trip and you're trying to find inspiration for places to visit. Instead of just typing in keywords like, beach vacation or historical landmarks, you can actually show the AI pictures of places that you've enjoyed in the past, or even images that evoke the feeling that you're looking for. And then it could recommend destinations that match your visual preferences.
Okay, that's a game changer, especially for people like me who are more visual thinkers. Searching with images just feels so much more intuitive and
I
inspiring.
agree. And it opens up so many possibilities for personalized and, serendipitous discoveries. You might stumble upon places that you never would have thought to search for otherwise.
This is really getting me excited about the future of search. It feels like we're on the verge of this major shift in how we interact with information online.
We are. And what's really remarkable is that, MegaPairs is based on these open source models. And it uses this readily available open domain data, meaning it's not limited to these big tech companies or research labs. Anyone could potentially contribute to this field and develop new applications.
Yeah, that's such an important point. This open approach is not only, driving innovation,
Yeah,
but it's also making AI more accessible and democratic.
exactly. It's a powerful reminder that groundbreaking advances can happen outside of these, traditional closed-off environments. MegaPairs is truly a testament to the power of open collaboration and shared knowledge.
Well, I think it's safe to say that MegaPairs has definitely given us a lot to think about today. From the technical brilliance of, its approach to just the mind-blowing potential it has for transforming the way we search, shop, research,
Hmm.
and just explore the world around us.
It has, and I really hope this inspires our listeners to consider the possibilities of AI in their own lives and, maybe even get involved in shaping this exciting future.
I love that. MegaPairs is not just like a technical achievement. It's an invitation to imagine and create a more visually intelligent and accessible world for everyone. And on that note, we would love to hear your thoughts. What are some other applications of MegaPairs that you can imagine? Head over to our website or social media to share your ideas and join the conversation. Until next time, keep those minds curious and those imaginations fired up.